Good day, ladies and gentlemen. We'll be looking at integration of odd powers trigonometric functions. So that's for Maths N6. Maths N6. So we want to see how to integrate odd powers of trig functions for Maths N6. So we'll start with tan cube. So usually with the power 3. The first target is knowing how to break the power 3 because the formula sheet for mathematics N6 does not have the power 3. The biggest power is 2 for trigonometric functions. So all power 3 is broken down like that, so that will be our first step. So to do tan cube, the first step will be to write it as tan square x over 7 multiplied by tan x over 7 dx. So that's our first step. So it's like taking a cube being a squared times a. That's what I've done there. Then after that, you go to page 1 of the Maths N6 formula sheet. You look for the formula for tan squared. So that formula will be 1 plus tan square x is equal to sec square x. So if you want to make tan squared a subject, you see 1 go to the other side. That should be page number 1, formula number 2 of the Maths N6 formula sheet. So we'll use that to replace our tan square. So our tan square now will become sec square. Then this x over 7, I would prefer to write it as 1 over 7x minus 1. So it means I'm making use of this formula to make tan squared a subject. Then I multiply by tan 1 over 7x dx. Then from there, the next target now will be to open the bracket so that I can get 2 integrals, then I'll move on with my integration. So if I open the bracket, the tan 1 over 7x will multiply there, form the first integral. So my first integral will be sec square 1 over 7x multiplied by tan 1 over 7x dx. That's my first integral. When I take tan 1 over 7x to multiply sec square, then followed by the subtraction sign, then my second integral will be tan 1 over 7x dx. So those are my 2 integrals. So from here, as an N6 student, this second one is not a problem because you can read the solution from page 2 of your formula sheet, column number 3, but you see the first one. The first one you see here is a product. So in this product, you realize that if you differentiate tan, you will get sec square. So if you get a product where you differentiate one item to get the other one, that is U substitution. So I'm going to start by doing U substitution for this part, the normal way. Then later I will use the power rule to also do it so that students can get different options. So to do your U substitution, you must check in the product. The one that you can differentiate to get the other one will always be a U. So if I differentiate tan, I get the whole sec square. So I would not prefer to say that U is sec because if I differentiate sec, I will get tan sec. So that one is not a proper, it's not a better option for me. So the best option would be to say that U will be equal to tan 1 over 7x, since the derivative of tan gives me the whole of sec square. So to differentiate that, if you are struggling, you just go to page 2 of your formula sheet for Maths N6. You see that the derivative of tan 1 over 7x will be 1 over 7 sec square 1 over 7x. So that is it. Then from here, I can make dx the subject, so that will take the place of that. So to make that, it's just like you swap the position of dx and the item on the right. So your dx will simply be du on 1 over 7 sec square 1 over 7x. So that is what I've done. So if I go back now to my integral, it will be the integral of sec square 1 over 7x multiplied by tan 1 over 7, which we call it u. So that becomes my u. Then multiplied by dx. My dx is now du here divided by 1 over 7 sec square 1 over 7x, then minus this other integral. I'm capturing it the way it is, And here I will not be replacing my tan by u, because we only do that in the product where we need u substitution. And also because for Math N6 page 2, you see the answer for this. So here, because of the u substitution, sec square can take care of itself. And to prove that the substitution was correct, you see that the x is completely eliminated and replaced by u. Then here you get 1 divided by 1 over 7. If you don't know how to do that, you just use your calculator up here. So that there is a 1, which will divide 1 over 7 to create a 7. And since 7 is a constant, it has nothing to do with the variable u. I take it out, so I'll get my du, which is that, then minus the integral of tan 1 over 7x dx. So I will now do this integral with respect to u. This will be 7 into u squared over 2, then minus. To do this one, I simply look at page 2 of my formula sheet. I look at page 2 of my formula sheet to see how do I integrate tan ax. So you see why I decided to be writing tan x over 7 as tan 1 over 7x, so that will be my a. So if I go to page 2 of my N6 formula sheet, the integral of tan ax gives me 1 over a leaves sec ax. So it's supposed to give me 1 over a. My a, you see it there, it's 1 over 7. Then the ln of sec 1 over 7x. So plus c. So that is my integral, but I must remember that my original function is in terms of x, it's not in terms of u. So if you use u substitution like this, you must replace your u by the value of u. So our value of u is tan, so it's somewhere. So this ends up being 7 over 2 tan square 1 over 7x, and 1 divided by 1 over 7 will give me 7 ln sec 1 over 7x plus c. So guys, that's how simple it is. We need to, that's simply what we have to do to integrate tan cube. But as I explained earlier, once I reach this step, rather than saying let u be equal to tan 1 over 7x, then I do all this story, I integrate in terms of u, there is also another option that we can use, which we call the power rule, which helps us to do integration faster. The power rule is on page 4 of the Math N6 formula sheet. So this is how the formula is written. If you are sure that you want to do u substitution, then you simply go to page 4 and make use of this formula. So we want to see how to use it to integrate from this stage where I've put my star or asterisk. I'll just copy it this side and continue with it. So let's say I got my integral and I got to this stage where I want to do integration by substitution. 1 over 7 tan x. So rather than saying let u be tan so that I differentiate to get this, all I simply do is use this formula, which is on page 4 of the Math N6 formula sheet, to do it fast. So how do I do that? Whatever I'm supposed to call my u, like you've seen here, we said let our u be tan 1 over 7x. I just slot it in the position of f in this formula. So I'll try to do that. So if I slot it there, it means I'm like copying this formula down in the position of f. I put my u, which is tan. So I'm putting tan 1 over 7x. Then my n will be the power of tan in the original equation. So the power of tan is a 1. Then the formula says you multiply that by the derivative of what you place here. You see what we place here is tan. Its derivative, as we've already seen from here, it's 1 over 7 sec square. So I get 1 over 7 sec square 1 over 7x dx. Then I'll just subtract tan 1 over 7x dx. So that is it. Now, to make sure that my u substitution is complete with the help of this power rule, all I need to do is compare what is written here to the original problem and make sure that they're still the same. So if we compare, you see that you have your tan 1 over 7x exists there, sec squared exists, but this 1 over 7 does not exist in the original problem. So in order to make sure that the two are still the same, I need a number that can take care of this 1 over 7 so that the two are still the same. I write it outside. So when I say taking care, it means I need that number that if I multiply a certain number by 1 over 7, I'll get 1. So I need the number that can balance it up so that the two are still the same. And you see that the only number to put here will be a 7. So that number that can take care of this 1 over 7, we simply put it up. Once you do that, it's the same thing as the U substitution. I started from here and came through this part to ending here. So I've done my U substitution in a single step. So I'm just going to write my final answer. So to write my final answer, I get my 7 there. Then for this portion, since we use the left hand side to handle it, the right hand side will be used to write our answer. So on the right, all I'm going to do is that whatever I place in the position of F on the left, I will do it on the right. So you remember, in the position of F, we place tan. So if we go to the right, we also place the same tan and make sure its power increases by 1. So our tan here, the power is 1. If you add 1 to it becomes tan squared 1 over 7x, then we divide by 2. So I've done this integral in 2 steps, but when you compare to this, you see how many steps we used. Then for that other one, it will be minus. The same thing we've done here, it will just give us minus 7, because if we take 1 divided by 1 over 7, the ln sec 1 over 7x plus c. So guys, as I always encourage my students, it's easier to use this formula to do U substitution than taking the normal procedure. But if you are more comfortable with the normal procedure, that's not a problem. But you can see how fast I've used this formula to just do my U substitution in 2 steps. So that is it for tan cube. Let's go to cot cube. So with trigonometric functions, tan and cot, I always say these are members of the same family. Because whatever you do to tan, you do to cot. The same thing with sine and cos. So to do this one, we'll just be following the same procedures we did with tan. So our step number 1 is to break the power 3 to be cot squared 7x, cot 7x dx. Then the next thing is go to page 1 of the formula sheet, just like we did there. We look for the formula for cot squared. That formula will be formula number 3 on page 1. And formula number 3 is 1 plus cot squared is equal to cosec squared. So if you make cot squared the subject there, you will get cosec squared 7x minus 1, or just multiplied by cot 7x dx. Then next step, we open the bracket to create 2 different integrals. So if I open the bracket, this one goes there, I'll get cosec squared 7x multiplied by cot 7x dx, then followed by the minus sign, then we multiply that, we get the integral of cot 7x dx. So just like before, the integral of cot 7x is on page 2 of our formula sheet. If you go to page 2, you look at column number 3, it will show you how to integrate cot 7x for mathematics NC's formula sheet. Then for this one, it's U substitution, because if we differentiate cot, we get cosec squared. So now I'll try to use our power rule to do U substitution. I just hope you are now comfortable with the power rule rather than say let U be cot 7x, which is a longer way. So this formula is on page number 4 of the Math N6 formula sheet. So to use it to do U substitution, all you need to do is check in your product what will you prefer to call your U. So as I've always said, in the product your U is always preferable to be the one that when you differentiate it gives the other one in full. So I can't say let U be cosec, because if I differentiate cosec, I get cot cosec. But if I say let U be cot, it will give me cosec squared. So it takes care of all of that. So whatever is my U, I'll put it in the place of F in that formula. So let's go in the position of F. I'm putting my cot 7x. Then my n will be the power of cot in the original problem, which is 1. Then I differentiate cot 7x. When I differentiate cot 7x, in case you are not sure, you just look at your formula sheet, page 2, the derivative will be negative cot 7x to negative 7 cosec square 7x then dx. You see, I've now introduced a bracket because of negative so that it doesn't change my problem. Then, to make sure that your u substitution is complete here, you must compare what is written here to the original problem to see if they are still the same. So if I compare, I see my cot exists, cosec square exists, but this negative 7 does not exist in the original. So I need a number outside to take care of the negative 7. So you see, I do it in one simple step. So the only number that can take care of negative 7 should be negative 1 over 7, so that gives me 1. So I will put negative 1 on 7 out. So this is the same thing like doing a u substitution by saying let u be cot 7x, look for du dx, and so on. So from here, I'm writing my final answer. So with my final answer, I get negative 1 over 7. Now to write the answer for this integral, I now use the right side of my formula. Whatever I put in the position of f on the left, I will do the same thing on the right. So what I placed there was cot, so I'll also take the cot there, and now the power of cot will increase by 1, so this will become cot square 7x, all this divided by 2, because the power has moved from 1 to 2, so I'm done with this portion. Then minus, now to integrate cot ax, what do? I go to my formula sheet. The integral of cot ax is 1 over a. My a is 7. So this is 1 over 7 ln sine 7x plus c. So guys, that is how easy it is to integrate cot and tan cube for trigonometric functions. So thank you very much.